Hey, everyone! Welcome back to the channel. Today, we're delving deep into the heart of JavaScript development, the state. We all understand the pivotal role state plays in any JavaScript framework, especially when crafting dynamic and responsive web applications. In this video, we're going to explore how to implement a state similar to React but in plain vanilla JavaScript, and we'll seamlessly integrate it with the JSX template engine. But before we dive into the coding goodness, make sure to check out my previous video on how to create a JSX template engine from scratch. The link is in the description below. This video is a direct continuation, so if you haven't caught up on that yet, I highly recommend giving it a watch. Alright, let's get started. So, what's the deal with the state? In the JavaScript realm, it's essentially a JavaScript object that houses your application's data. Any tweak in the state triggers an update in the user interface. Today, we're going to create a single state object to corral our application's data, and we'll witness how changes in that state effortlessly ripple through our UI. We're going to follow the hooks pattern, inspired by React. Specifically, we'll be crafting two hooks: useState and useEffect. But before we jump into the code, let's get on the same page. What exactly is proxy? Well, the proxy object lets you create an object that steps in for the original object. It can redefine fundamental object operations like getting, setting, and defining properties. Proxies are often used for tasks like logging property accesses, validating inputs, or even sanitizing data. Absolutely, let's integrate that section seamlessly into the script. Now, before we jump into the code, let's gain a better grasp of the proxy with a practical example. Imagine we have a checkout object initialized with properties like price, quantity, and total. However, there's a quirk: when we modify the quantity to 2, the total remains stubbornly at 100. This inconsistency arises because any change in quantity or price requires a manual update of the total. Enter the proxy. The proxy takes two parameters: the object to be proxied and the handler object. This handler object is where the magic happens, encapsulating methods like get and set that get invoked when operations are executed on the object. In our scenario, when we try to access the total property of the checkout object, the get method of the handler object comes into action. The get method, taking two arguments, the target object and the key being accessed, examines if the key is total. If it is, it returns the product of price and quantity; otherwise, it retrieves the value associated with the key from the target object. Now, we have a basic understanding of the proxy. Let's apply this proxy magic to create a state similar to React. First things first, let's create a new file in the src core folder and name it state.js. This file will house our custom hooks. We kick things off by creating a class called Observer. It's the Sherlock Holmes of our state, keeping an eye on changes with its add and notify methods. Now, let's add some helper functions into the mix. IsFunction, this function validates whether the target is a function. It comes in handy when we need to check the type of an entity to ensure it's a function. IsObject, checking if the target is an object is crucial, and that's precisely what this function does. It helps us ensure that we're working with an object when needed. Clone, when we need to copy data from a source to a target, particularly for object data, this function comes to the rescue. It facilitates the process of creating a duplicate, ensuring smooth data handling. Now, let's get to the meaty part, the hook functions. useState, this function is the powerhouse for state creation. It accepts the initial state as an argument and returns the current state along with the function to update the state. Here's the magic: it initializes a new observer object and a new proxy object. The function it returns is responsible for providing the current state, while the setter function is the hero used to update the state. The intentional design of the function returning the current state enables effective tracking of changes in the state. useEffect, now, this function is all about keeping tabs on changes in the state. It takes a callback function as an argument and gets triggered whenever the state undergoes a change. It sets the callback function as the target func and executes it. After that, it resets the target func to null. Here's the cool part: no need for a dependency array because useEffect inherently monitors changes in the state used within the callback function. Setter, now, this function is the secret sauce for modifying the state. It takes a proxy object and an observer object as parameters. The function it returns is the maestro responsible for updating the state. It's Sherlock Holmes and Dr. Watson combined. It determines whether the data is a function; if so, it invokes the function with the current state as an argument. Otherwise, it updates the state with the provided data. Following the state update, it triggers the notify method of the observer object. Create options, this function is the architect behind the scenes, generating the options object for the proxy. It takes the observer object as input and returns the options object. The options object is like a Jedi, incorporating a get method that activates each time the state is accessed. It adds the function to the subscribers set and returns the value associated with the key from the state. If the key's value is an object, it's like creating a new galaxy. It generates a new proxy object for that object and returns it. Now, let's bring this state.js file into our JSX runtime. The only tweak we're making is integrating the useEffect function into the JSX runtime. This ensures that the appendChild function gets the updated state every time there's a change. Alright, fam, we're firing up the Webpack server. Let's see this baby in action. I've created a counter component and seamlessly integrated it into the app component. You know, just another day in React paradise. In the counter component, I've added a state using our custom useState hook. And guess what? On the click of that button, we're updating the state like a maestro conducting a symphony. Now, let's witness this React symphony in action. Voila! The state changes just as we orchestrated it. But hey, we're not stopping there. We're throwing in the useEffect hook for that extra spice. First, we're casually adding the useEffect function. It's got a console.log statement, because who doesn't love a good log, right? This function fires off when the component loads, giving us that on-mount vibe. But here's the kicker, you update the state, and it stays chill. Why? Because we're not touching the state inside the useEffect function. It's like a mysterious on-mount ritual. Now, let's take it up a notch. We're adding the state to the useEffect function, breaking the fourth wall of React mysteries. Inside that useEffect, we're embracing the state, giving it a warm hug. And guess what happens? Whenever the state changes, the useEffect function waltzes onto the stage, delivering its console.log performance. And there you have it, my coding compadres. Everything works like a charm, just as expected. State management, useEffect, consider them conquered. If you enjoyed this React rollercoaster, make sure to share it with your coding crew and comment down below on what React mysteries you'd like us to unravel next. Until next time, happy coding, stay caffeinated, and may your bugs be as elusive as that last sock in the laundry. This is BitBuddy signing off, catch you in the next one.